be doing an integral from 0 to pi over 2 of sine squared of x divided by sine of x plus cosine of x. This integral can be done using a Weierstrass substitution, which is a very special substitution that converts your integrand full of trig functions to an integrand full of polynomials. That requires a lot of algebra, so we are not going to do that. We're going to do a simpler method. And the way that we start is that we're going to realize that we can write each sine of x as a cosine of x that is phase shifted. So we're going to do that, and then we're going to rewrite this integrand using this relationship. So every sine will be rewritten as a cosine, and every cosine will be rewritten as a sine. So we're going to do that. And what you may realize while we're doing that is that in the denominator we have sine of x plus cosine of x. If you have much intuition about trigonometry, you'd realize that this is just another sinusoidal wave. So you can rewrite that as another sinusoidal wave. But before we do that, we're going to do a variable substitution. So we're going to say that pi over 2 minus x is equal to u, and that would be our variable substitution. So we're going to do that, and we're going to get two bounds of integration. We're going to get 0 and pi over 2. And our du will be negative dx. Alright, we got that done. And now we get our new integral. It's going to be negative, it's going to be from negative pi, it's going to be from pi over 2 to 0 with a negative out in front because we have that negative dx factor, and this will be our new integrand. Now what you will realize is that we can change the bounds of integration quite easily. Because that's a negative, we can say it's from 0 to pi over 2, and so we have our new integral that we can work with. And the variable substitution was with u, but because u and x's, those are just arbitrary variables, we can just say that we're doing in terms of x. Now we're going to say that I equals this integral, which is the integral we're trying to solve. And what we're going to do is we're going to say that we're going to try to calculate 2 times I. So I plus I, basically. So we're going to have cosine squared of x plus sine squared of x then. And then our denominator would be just the sine of x plus cosine of x. So all we did was add the same integral to itself twice, and then we ended up with this. Now cosine squared of x plus sine squared of x is 1, so we don't have to deal with any trig expressions in the numerator. So what we're going to get is a new integrand. Remember what I said earlier about our denominator. Sine of x plus cosine of x, that is just another trig function. That's the square root of 2 times cosine of pi over 4 minus x. So we can pull that 1 over square root of 2 behind the integral because it's a constant, and then we just have this integral. Now what we need to do then is another variable substitution. So we're going to say that u equals pi over 4 minus x, and this will give us new bounds of integration. This will give us negative pi over 4 and pi over 4. So do that, and then du will be negative dx again. So we're going to have a negative out in front, so we're going to have negative 1 divided by the square root of 2, and it's going to be from it's going to be from pi over 4 to negative pi over 4 of our secant of x. Again, x and u, so they're just arbitrary variables. And what we realize is that we can again change the bounds because we have negative up front, so we'd like it from a negative to a positive for the bounds. So we do that. Another thing we do is that we know that secant of x is a even function. So if we're integrating from negative a to a, that's going to be 2 times 1 divided by the square root of 2 times this integral, which is from 0 to pi over 4 of secant of x dx. And we can do this as long as there are no singularities between negative pi over 4 and pi over 4. And because secant of x is an even function. So this integral of secant of x is actually has a well-known formula. It's the natural log of secant of x plus tangent of x. And it's from 0 to pi over 4. And this is all equal to 2i. So for our lower bound, we can see that it vanishes because tangent of 0 is 0 and secant of 0 is 1, and that leaves us with the natural log of 1 for the lower expression, for the rightmost expression. So that vanishes. So I have 2 divided by the square root of 2 times the natural log of secant of pi over 4. Now that is just 2 divided by the square root of 2, because it's the reciprocal of the cosine of pi over 4, and it's plus 1. So natural log of that, and then we have 2i equal to this. So to get our final answer, we divide by 2, and what we get at the end of the day is 1 divided by the square root of 2 times the natural log of 2 divided by the square root of 2 plus 1. And that is our final answer.